So now we're at the calculus section of the paper, module 3. Question 5, evaluate the limit. And to evaluate limits, we first always do direct substitution. So we're going to replace the x values with negative 3, alright? So negative 3 square, we square negative 3, we get positive 9. 5 times negative 3, that's negative 15, plus 6. In the denominator, 6 times negative 3, that's negative 18, plus 18. So the denominator obviously is 0. And the numerator, 9 and 6, 15. 15 take away 15, 0. So 0 is 0, so we don't accept that as a solution. We say this is indeterminate. So 0 is 0, so one thing we could do is rewrite the problem by factorizing. So let's factorize the numerator, so limit as x approaches negative 3. So factorize the numerator. The factors of 6 are what? 6 and 1 are 3 and 2. So it looks like 3 and 2 will factorize it. And then the denominator, 6x plus 18, common factor there is 6. So factor out 6. In the bracket we'll be left with x plus 3. So x plus 3 divided into itself. Alright, leave just what are we left with? X plus 2 over 6. And now we can replace x with negative 3. So replace x with negative, we get with negative 3 plus 2 over 6. And what's negative 3 plus 2 now? Negative 1 over 6. Alright, so that's our limit. Part B, determine the gradient of the curve at the point x equal 4. So the gradient is given by dy by dx, so let's differentiate. Dy by dx, so multiply by the x power, 2 times 6, 12. Subtract 1 from the x power, we're left with x to the power 1. Notice the second term here is a product, 2x squared times cos x. So we use a product rule. So we're going to differentiate 2x squared times cos x using the product rule. So the product rule, differentiate the 2x squared, we'll get 4x. We'll leave the cos x alone. Plus, this time now we'll leave the 2x squared alone. And differentiate cos x, we end up with negative sin x. Alright, so this becomes, so therefore dy by dx would be equal to 12x, distribute a negative, so I get negative 4x cos x, and then distribute a negative here, it's like we're multiplying by negative 1, so negative times negative, I end up with now positive 2x squared sin x, and we are told x equal to 4, so replace x with 4, so we substitute x equal to 4, we end up with dy by dx. Dy by dx equal to 12 times 4, that's 48. Minus 4 times 4, that's 16 cos 4. Plus x is 4, so 4 squared 16 times 2, that's 32 sin 4. So one important, and we can use our calculator to do the rest. One important thing is when we're doing this problem, we have to assume that 4, the x value here, 4 is, we have to assume it's radians. So notice that we didn't see a degree, so we have to assume that the angle, the value of 4. So when you're doing work in these trig functions, trig values, put your calculator in radian mode or in R mode. Alright, so put the calculator in R mode. Alright, so we have to assume it's degrees since there's no degree there. So we have to assume it's radian, sorry. Let's do the calculation quickly. So I'm getting 34.24. Let's move on. Differentiate. So fx, so we can say dy by dx, or we could say f prime x represents a derivative. So this, of course, would be the quotient rule. So quotient rule, we differentiate the, so when you have a quotient, function over a function, differentiate in numerator first. So differentiate in numerator sin x, we get cos x, and we times it by the denominator, which is ln x plus 2 plus 7, and it's minus, and then now we differentiate the denominator, log x plus 2 plus 7. So how differentiate the log function? Differentiate what's in the bracket. So differentiate x plus 2, we get 1. Just differentiate the bracket and put it over itself. That's how we differentiate a log function. And differentiate 7, we get 0. Differentiate a constant to get 0. So we just 1 over x plus 2 times the numerator. So differentiate the numerator, we get cos times the denominator minus, and then we alternate, differentiate the denominator times the numerator. All over this, all over the square of the denominator. I won't even attempt to simplify this. Let's move on. Part D. The vertical displacement in meters of a particle on a ballistic trajectory is given as y, which y is a function of t, so y equals 15.7 t minus 5t squared, where t is measured in seconds. So the thing is going up, vertically up. Well, we're not told if it's going up or down, but it's traveling vertically. Determine the displacement when t is 0. So when t is 0, y equal to, so we find the y of 0, replace t with 0, right? So y of 0 replace t with 0 is 15.7 times 0 minus 5 times 0 squared, which is 0. So the displacement is 0 when t is 0. Determine the velocity, and the velocity, to get velocity we differentiate displacement. So velocity is change in displacement over time, alright? So that's dy by dt. So this is y. So dy by dt, you multiply by the t power and subtract 1 from the t power. So differentiate 15.7t, that's 15.7. Differentiate the next term, 2 times negative 5, that's 10t to the power 1, which is just t. T to the power 1 is just t. So multiply by the power. Here you multiply the power. You'll be left with t to the power 0, which is 1. So all we have is 15.7. Multiply by 2. The t power will get negative 10t to the power 1. So that's the expression for velocity. Determine the time at which the particle reaches its maximum height. So if you think about it, the particle is traveling up. And when it reaches maximum height, it will stop and then start to come back down. So when it reaches maximum height, when it's maximum height, it stops, which means the velocity is 0. Alright? So this, at its maximum height when the velocity is 0. So for the velocity, we have this expression for the velocity, 15.7 minus 10t. So at the maximum height, the velocity is 0. And what's the expression for the velocity again? 15.7 minus 10t. So 15.7 minus 10t is equal to 0. Therefore 15.7, group the 10t over here, equal to 10t. Divide both sides by 10. So 10 cancel 10 there. So t equal to 15.7 divided by 10, which is 1.57 seconds. So after 1.7 seconds, the particle will reach its maximum height. And determine the maximum height. So remember the height, the formula for the vertical displacement. Let me put it down here. It's 15.7t minus 5t squared 15.7t, 15.7t minus 5t squared. That's the formula for the displacement, in this case height. And we want to find it's at its maximum height when t is 1.57. So we're going to replace t with 1.57. So we substitute 1.57 for t. So 15.7 times t, which is 1.57, minus 5 times 1.57 square. And we end up with y equal to, and that's 12.32, and the height is given in meters. Right? State whether the acceleration dv by dt is a constant for the entire flight. So remember the expression for v was the expression we have for v? So v was 15.7 minus 10t. 15.7 minus 10t. 15.7 minus 10t. So the acceleration is the same as dv by dt. So differentiate any constant, 15.7, that's 0. Differentiate 10t. Remember the rule for differentiation, multiply by the t power. We get minus 10 times t. Subtract 1 from the power is t to the power 0. And t to the power 0 is 1. So it's just negative 10, which is a constant. Alright, so the answer to the question, dv by dt is a constant. So the acceleration a is a constant, and that constant is negative 10. And it is in terms of the, I guess the unit would be meter per second square if we were to put a unit for acceleration. So the negative acceleration, I mean it's slowing down. So what if you throw a particle in the air, it will slow down. So that's why the acceleration is negative. Alright, so that's what a negative acceleration means. The particle is slowing down. Alright, part E. Given a function f such that f of xy, so f is written in terms of two variables, x and y, 3 root x times y squared. So I'm write f of xy again. 3 root x times y squared. Now root x can be written as x to the power of half. That's another expression for root x times y squared minus y over 2. And the x, I want to bring it up because I want to differentiate it. So x is in the denominator. So x is x to the power 1. And one of the laws of indices is that we can bring up the term, but we have to change the sign of the power. So we can rewrite the function as that. Let's differentiate now. Partial derivative. Alright. So we differentiate with respect to x, which means we're going to treat the y as a constant. So partial derivative of x, we're going to treat the y as a constant. So we're going to multiply by the x power. Since it's respect to x, we're going to multiply by the x power and subtract 1 from the x power. So half of 3, that's 3 over 2. Subtract 1 from the x power. So half minus 1, that's negative half y squared. So all we did there was multiply the term by the x power and subtract 1 from the x power. So half minus 1, negative half. Next term, same thing. Multiply the term by the x power. The x power is negative 1. Multiply negative 1 times negative. That's positive y. Alright, so I will subtract 1 from the x power. So minus 1, that's minus 2. So notice in both instances, all we did was multiply the term by the x power and subtract 1 from the x power. Since it's a partial derivative, we treat the y as a constant. Question 6. A cylinder has a radius r, centimeter, and height h centimeters. The height is increasing at a constant rate of 2. So the height, we are told, the rate of change of the height, I must put that what we are given, the height is dh by dt. So the rate of change of the height with respect to time is 2 centimeters per second. Alright, notice it's changing every second by 2 centimeters. Alright, so the volume of the cylinder is pi r square h. Determine the following: an expression for the rate at which the volume is changing per second. So what we're asked to find is the rate of change of the volume, and the rate of change of the volume with respect to time is dv by dt. And by the chain rule, dv by dt, we can write it as dv by dh times dh by dt. Now dh by dt we know, and the thing about the chain rule is like these cancel in a sense. So dv by dh times dh by dt is same thing as dv by dt. Alright, so let's work out dv by dh. Now here we have v equal pi r square h, and h is h to the power 1. So to find dv by dh, we are differentiating with respect to h, which means we multiply by the h power and subtract 1 from the h power. So multiply by the h power, which is 1. So we end up with 1 times pi r square h. So, and then we multiply by the h power, subtract 1 from the h power. So we end up with h to the power 0 times dh by dt, that's 2. And of course, h to the power 0 is 1. So all we have left is just 2 pi r square. So the expression for dv by dt is 2 pi r square. So in part 2, the rate of change of the volume when r is 10, so rate of change of the volume, that's still dv by dt. So remember, dv by dt, again, is 2 pi r square. We are told r is 10, so it's 2 pi times r square, so times 10 square. So 10 square is 100, so 100 times 2, so 200 pi. And the unit for volume is centimeter cube in this context, and the unit for time is second. So the unit will be cm cube per second. Evaluate the following integrals. So we're integrating. That's what integration sign should be here, right? Let's integrate. So we integrate. So 4 cos 4x plus 10. We simply, so this is 4 cos, well, integrate cos, we get sine, right? So integrate cos, we get sine. Should be 4 sine, the bracket doesn't change. And of course, we divide by the x coefficient, which is 4. Alright, so remember, integrate cos, it turns to sine. Alright, and the coefficient here, the derivative of the bracket here, which is 4, coefficient of the x, we divide by the 4. And notice what's in the bracket doesn't change. Integrate 7 over x. So the integral of 1 over x is log x. So look, 7 over x is really 7 times 1 over x. Alright, so this will be 7 times log x, and there's no limits here, so we put a plus c. So alright, so the integral of 7 over x is 7 log x. Next one. Integrate there between two limits now, 4 and 2, so no need for a plus c. So 8x cubed, the rule, add 1 to the power. So let me write it properly. So 4, the limits 4 and 2, 8x cubed plus 4x minus 1 dx. Alright, so the integrate, the rule is add 1 to the x power, divide by the x power. So add 1 to the x power, Other one we get 4 divided by the new power 4. Here the power is 1. Other one we get 2. So we divide by a new power 2. Look at minus 1 as minus 1 times x to the power 0. So you can do all constants like that. So add 1 to the x power, you get 1 divided by 1. So the very, very basic rule, add 1 to the power and divide by whatever the new power is. Alright, so after we do that, we form two brackets. In the first bracket, replace x with the top number, and in the second bracket, replace x with the bottom number 2. So in the first bracket, we're going to replace x with the top number 4. So by the way, let's just simplify this a little bit. 8 over 4, 4 into 8, that's 2. So that's 2x to the power 4. 2 into 4, that's 2, so that's 2x squared. Alright, so this is, let me just put it a little bit neater before I do that. Let me just simplify this. So this is 2x to the power 4 plus 2x squared, 2 into 4, so that's 2x squared, minus 1x, limits 4 and 2. Alright, so we form two brackets. The first bracket, are going to replace x with the top value 4. So this is 2 times 4 to the power of 4. Now, 4 to the power of 4. 4 to the power of 4 is 256. 4 to the power of 4. You multiply 4 by itself 4 times. So 4 times 4 times 4 times 4. That's 256 times 2. That's 512. Plus 4 squared, that's 16, times 2, that's 32, minus 4. In the second bracket, we replace x now with 2 in the same expression. So replace x with 2, 2 to the power of 4, that's 16, times 2, that's 32. 2 to the power of 2, that's 4, times 2, that's 8, minus 2. So, you can use a calculator and work this out. This seems to work out to 502. Alright, let's continue. Determine the area bounded by the curve f of x equal to that and the x-axis. So a curve, notice the curve, the x squared is a negative thing there, so a curve, it will look something like this. So we want the area bounded by the x-axis and the curve. So alright, so we need to find where the graph, so we first need to find where the graph cuts the x-axis. And to get where the graph cuts the x-axis, we equate f of x to 0. So negative x squared plus 9x minus 8, we equate it to 0. Remember the graph cuts y-axis. Sorry, the graph cuts x-axis when y is 0, so we equate f of x, which is the same as y, equate it to 0. So let's solve this equation. Now to solve it, well, you can solve several ways, but let me try and make the x squared be a positive. So what I can do is multiply both sides by a minus 1. So I'm going to multiply both sides of the equation by a minus 1. So minus 1 times the right hand side is minus 1 times 0 is 0. Minus 1 times the x squared term, minus times minus is positive x squared. Minus 1 times the 9, that's minus 9x. And minus 1 times the 18, the negative 18, that's positive 18. Same equation. All I did there was multiply both sides by minus 1. Alright, so we have an easily quadratic now, so we can solve it. Let me use factorization to solve it. Factors of 18, 6 and 3. So we can write it as 6x minus 6, x minus 3. Notice if we expand this bracket, we should get this here, right? So if we equate both brackets to 0, so when we're solving by factorization, we equate the factors to 0, right? 3 and 6. So this function will cut the x-axis at 6 and at positive 3. And we find those by equating the function to 0 and solve. So to find the area now, we're going to integrate the function between the limits 6 and 3. Alright, let's integrate now. Alright, so we know the graph cut the x-axis at 6 and 3, so those are our limits. So here's the original function, we're integrating limits. So integration, again, we add 1 to the power, x power, and divide by the new power. Alright, so add 1 to the power, we get negative x squared, the new power, which is 2, 9x squared, divide by 2, add 1 to the power is cube, x to the power of 3, divide by the power 3, right? Add 1, 2, divide by 2, and integrate negative 18, it's negative 18x. Look at negative 18 as negative 18, x to the power 0. So add 1, you get x to the power 1, divide by 1. And the limits are 6 and 3. Alright, so to get the area, we form two brackets. In the first bracket, replace x with the top number. So here is minus x to the power of 3. So 6 to the power of 3, that's 6 times 6 times 6, that's 216. Divide by 3, that's negative 72. In the next term, 9x squared, so it's 9 times 6 squared, divided by 2, so it's 9 times 6 times 6, divided by 2, that's 162. I need more space. So that's 162 minus 18 times 6, that's 108. So minus, now we're going to replace x with positive 3 in the second bracket. So this time now, replace x with 3, so 3 cubed, that's 27. 27 divided by 3, that's 9, well, negative 9. Next one, so it's 9 times 3 squared. 3 squared is 9, so 9 times 9. 9 times 9, that's 81. And 81, so it's 81 over 2. Or let's look like 40.5. And if either one, minus 18 times 3, so 18 times 3, that's 54. Alright, so our final answer. So the first bracket, all of this work out to be negative 18, minus second bracket work out to be negative 22.5. So this becomes negative 18 plus 22.5. So the final answer here is 4.5. And its area, so 4.5 square units. We don't know whether it's centimeter or meter or whatever, right? So 4.5 square units. That's our area. And the final part of the question, solve the following first order differential equation with the given initial condition. So we have x times dy by dx equal 4x to the power of 4 plus x cubed plus 3x. Alright, to solve differential equations, we need to find y. So what we can do is to get dy by dx by itself, we can divide both sides by x. So we can divide both sides by x, divide the left hand side by x cancel x, we're left with dy by dx. Divide each of these terms by x, the 4x to the power of 4. Subtract 1 from the x power, that's 4x cubed. The x cubed divided by x, that's x squared. And the 3x divided by x, that's positive 3. So dy by dx is equal to all of that. 4x cubed, x squared, plus 3. So how it works, when you have y, you differentiate to get dy by dx. And when you have dy by dx, you will integrate to get y. So let's integrate now to get y. So solving the differential equation, you basically ask to find the expression for y. And if you're moving from dy by dx to y, you would differentiate. Sorry, if you're moving from y to dy by dx, you would differentiate. And if you're moving from dy by dx to y, you integrate. So let's integrate. And how do we integrate? We add 1 to the x power and divide by the new power. Add 1 to the x power. You get 3 divided by the new power 3. Look at this as 3x to the power 0, right? Add 1 to the x power, you get 3x to the power 1. Divide by 1, you get 3x. And of course, we put our plus c. Alright? So we need to find a constant now, and we substitute these. So when x equals 0, y equals 4. So if y equal to 4, x is 0, so all of these terms become 0, x cubed 0, 3 times 0, 0. So 4 equal to everything. All we have on the right hand side left is c. So c is 4. So therefore, y is equal to 4x to the power. No, that's not what y is. Well, y is this. Notice that, so that's y is x to the power 4. X cubed over 3. Plus 3x plus c. And we know the value of c is 4, right? How we get c is 4? We substitute here. Y is 4 from x is 0. Alright, from that. So that's our solution. That's it. Goodbye.